ExoMars 2016 is a complex mission. It's a technology demonstrator, a way of relaying information between the lander, the orbiter and the Earth, and it's a science mission. The high-resolution camera, CaSSIS, acts as the orbiter's scientific eye. This is CaSSIS being tested at the University of Bern in Switzerland, where it was built. The camera is actually a telescope with a sophisticated detector that can provide colour and stereo images over a 9.5 kilometre wide strip.
We begin by pointing 10 degrees in front of the spacecraft as the spacecraft moves over the surface of Mars. Once we take our first image, we then use a mechanism to turn the telescope around by 180 degrees so that we're pointing 10 degrees backwards. And in this way, we can construct a stereo angle of about 20 degrees, allowing us to get the 3D topography of the surface. This technique allows us to get higher resolution because we can build the telescope for one specific direction.
CaSSIS will be able to examine recurring slope linea on the surface of Mars at different times of the day over the planet's seasons. The linea are the dark lines believed to be associated with liquid brine that increase in size during the Martian spring and summer and fade away during autumn and winter. Also on board the orbiter is the NOMAD instrument, built at the Belgian Institute for Space Aeronomy on the site of the Royal Observatory. NOMAD will be the first high-resolution instrument of its kind around Mars. It consists of 3 spectrometers, 2 working in the infrared and 1 in ultraviolet, and it can identify trace gases, such as methane, in the atmosphere.
They will be looking directly at the surface of Mars. That's what we call nadir observation. That's one kind of observations. The other kind of observations will be looking at the sun during sunsets and sunrises. And doing both kind of measurements, you can derive more information on the atmosphere of Mars.
The European NOMAD and CaSSIS instruments are joined on the orbiter by 2 Russian instruments, the ACS Atmospheric Chemistry Suite and the Fine-Resolution Epithermal Neutron Detector, FRIEND, which will map water ice deposits, both on the surface and up to 1 metre deep, 10 times better than existing measurements. The Schiaparelli lander, seen here in a clean room at Thales Alenia Space, is primarily for demonstrating landing technologies, but it also carries a descent camera, Decker, and a small science payload. A suite of sensors called DREAMS will characterise the dust and Martian environment, and the Amelia package will collect the valuable entry and descent information. The presence of methane in Mars's atmosphere offers intriguing possibilities. It could result from geological hydrothermal reactions in the planet's mantle, or it may be from simple life forms like microbes. Whatever the origin, Mars is no longer a dead, red, dusty planet, as it's much more dynamic than previously thought. But the information gathered by the ExoMars Trace Gas Orbiter and the Schiaparelli lander will not only further our understanding of the planet, it will also help the ExoMars 2018 mission, which will include the first European rover on Mars.